We now get to begin section 2.4, and this is where we get to actually start graphing the trigonometric functions. And there's a lot of detail in the book that needs to be followed, because once again these notes are pretty much to look at the specifics, in particular specific examples. And so we're going to begin with the graph of y equals 5 sine of x. Now if we look at this, the amplitude, or in other words how high and low it gets, is the absolute value of 5, this number out here, which of course equals 5. Now what this says is we're going to take the normal sine curve and then we are going to boost it up by a factor of 5. And so what that means is instead of going from 1 to -1, it's going to go from -5 to +5. And we're still going to have some very important points along here. And as a general rule, I'm going to just use every mark to represent pi over 2. Now the really nice thing about creating our own graphs in this manner is the fact that we can force it to look the way we want it to look. Now sine always begins at 0, and then every pi over 2 it's going to go to either the extreme or the middle. So this pi over 2, it's going to go up to the extreme up here at 5. At pi it's back to 0. At 3 pi over 2 it goes down here to the extreme -5, and then we get 2 pi here as well. And so we have some very good points here. Realize there was nothing else that had to be taken care of, just the 5, and that represents the change in amplitude. And so it's important to realize that the sine curve has a very distinct look. It's going to keep on going up and down like this. And whenever we do a graph, the bare minimum is I want to see at least one entire period. In other words, this was going up and it continues on, then it eventually comes down, then it comes back up. And so it did go at least one period. If it takes 2 or more, I still want you to fill up the graph area, but at a minimum, I need to see one period. Example number 2. Y equals 3 sine of 1/2 x. Okay, the amplitude, much like we did in example number 1, is the absolute value of this number right here, and that would be simply 3. But we also have a period change. The period is going to change a little bit as well. And what we need to do is the period is always 2 pi over this expression right here, whatever is being multiplied by the variable at this point. And so it's going to be 2 pi over 1/2, which of course equals 4 pi. Now what that does is that changes our graph a little bit. Once again, first thing we're going to do is what our maximum and our minimums will be a maximum of 3, minimum of -3. And I want to have the 4 marks out here. But what I want to make sure is instead of just making this 2 pi, I need to get at least one period. And it's very important to realize that sine has a period of 2 pi, so that's why I chose 2 pi. In this case, the period is 4 pi, so I'm going to change that to become 4 pi. And then, of course, each of the individual marks then become required to be multiples of pi. But once we get this, then it's very simple to draw the graph, because sine always starts at 0. And then at each mark, it's going to go to either the extreme or to the middle. The extreme and the middle. And then just extending it just a little bit and realizing that we're going to have this sinusoidal curve going up, down, so on and so forth. Once again, we are showing one entire period, and we have just adjusted. Now realize if the graph is given, you're going to have to force, at 0, 0, and then at pi you'll put it up at 3, and at 2 pi you'll put it at 0. You're going to have to do some mental juggling here to keep that all straight, but it is important to realize that you need to be able to do these particular steps. Example number 3 is y equals 3 cosine of x. So we're going to look a little bit at, how does cosine different from sine, but the principles are pretty much the same. Once again, we have an amplitude. How high and low is it going to get? Same rules. The absolute value of 3, which is equal to 3. We don't have any number being multiplied by the variable here, so we don't really have to worry about a period change. The period is still 2 pi. So let's look at how we're going to draw our graph. Amplitude tells us 3, so we're going to have to go a positive 3 and a negative 3. And then along the x-axis, I'm going to put 4 equally spaced marks. And notice the period is going to be 2 pi, because the period of cosine is also 2 pi. So that means 2 pi is going to go there, which would mean this would be pi. But the nice thing, once again, each of these marks represents either a high, a low, or right in the middle. Now cosine's a little bit different. Cosine doesn't start at 0, 0. Instead, it starts at the extreme, one of the extremes. And in particular, if there's no eigens anywhere, it's going to start at the upper extreme. So we start at the upper extreme, go to 0, lower extreme, 0, higher extreme. And cosine also has a sinusoidal curve. It's just shifted a little bit. Compared to what we had. And so this would be the equation y equals 3 cosine x. The final example in this first group is example number 4, which is y equals 3 cosine of 1/3 x. And once again, we have the amplitude concern, this number here. The absolute value of that is 3. So that's no problem. The period, we always calculate by doing 2 pi over the number that's being multiplied by the variable right here, which is 1/3. Well, of course, 2 pi over 1/3 equals 6 pi. And so think about how that's going to be changing our graph. So once again, draw the axes. I know I'm going to go up to a positive 3 and down to a negative 3. And I need to have 4 marks here. Although the 4 marks aren't going to be all that nice, but we can deal with them. Now there's 6 pi. And it's very easy to mark or label this as 3 pi because that's the halfway mark. Now this one would actually be 3/2 pi, and this would be, 9/2 pi. But we don't really need to label them. Now cosine does not start at 0, 0, and barring any negatives anywhere, we know it starts at the positive extreme. So we know that point's going to be there. And then the same thing applies. At what would technically be 3/2 pi, we're going to be at 0. At 3 pi, we're going to be at the bottom extreme. At 9 pi over 2, we'll be back to 0. And at 6 pi, we're at the upper extreme. And so what we can do, yet again, is to draw this nice smooth curve, or as smooth as we can get it, so that it looks like that. And so this would be 3 cosine 1/3 x. And once again, it all depends on what the graph that is given to determine. I mean, for the most part, all of these graphs look pretty much the same. But that won't happen when you actually get different scales on your graphs. Okay, the next group says, without graphing, determine amplitude or period as requested. So, number 5. Y equals -4 sine of x. And we are asked to find the amplitude. Well, the amplitude is simply the absolute value of this number right here, the number out front. So the absolute value of -4 is 4. The amplitude is 4. Number 6. Y equals -2 cosine of 1/3 x, and we are asked to find the amplitude. Once again, we got the simple one. Amplitude is pretty simple. Period takes a little bit of thought. The amplitude would be the absolute value of this number right here. The absolute value of -2 is 2. Number 7. Y equals 3/4 cosine of -4 pi over 5 x. And we are asked to find the period. Now the period is the one that actually takes a little bit of calculation, but it's really not that difficult. The period is equal to 2 pi over this number here. Now we do not need to worry about the SIGIN. So this would be 2 pi over 4 pi over 5. Now some quick calculation shows us the pi's will cancel each other out. This will simplify to that, and so it becomes, as the final answer, 5/2. The period would then become 5/2. Number 8. Number 8 gives us some detailed information about predator and prey population, stuff like that. Basically, M represents the population of the predator, and that is given as 750 plus 125, the sine of pi over 6t. And the population for the prey is given with capital N, which is 12,250 plus 3,050 cosine of pi over 6t, where t represents time, and in months is what it says. And so we are asked to find the period of each one of these functions. So the period says all we're really interested in are these numbers right here. Now it's very important, or one thing if we would notice, pi over 6 is the same in both of these. These represent other sort of transformations that we'll get to in just a little while, but what we're really concerned with for the period is pi over 6, and they both happen to be the same, so all we have to do is to find one of them, and we have answered the question to both. So once again, the period is determined by 2 pi over pi over 6. Some quick calculations. This becomes equal to 12. The period would be 12. So in other words, it just starts over every 12 months, or every year. The number of predators and prey will fluctuate, going up and down by particular amounts.